Hi guys, this is lesson 5 in unit 5. We're going to talk about graphing piecewise functions. Let's start by talking about the definition of a piecewise function. What is a piecewise function? A piecewise function is a function that is defined by multiple pieces. Each piece is defined over a specific interval of the domain. This definition is not going to make sense to you unless we take a look at our first example. Let's take a look at our first function, which is an absolute value function. We have f of x equals the absolute value of x minus 3. Let's graph this function on the grid using the TI-84 calculator. So the first thing I'm going to try and do is to put this function in the calculator. I'm going to go to y equals. I'm going to put the absolute value function in, and to get the absolute value function in, I'm going to have to use the math key, and then I need to use the right arrow to go to number, and then I'm going to hit enter, and the absolute value function now in y1, all I need to do is to put x, leave the absolute value function, and minus 3. So graphing this function in on my grid, I'm going to have this graph, and to get accurate points, to make an accurate graph, I'm going to have to go to table, which is second graph, and I'm going to have to graph exact points. So I'm going to use 0, -3, 1, -2, 2, -1, 3, 0, 4, 1, 5, 2, and 6, 3, because my grid goes from 0 to 6 in the first quadrant. So I'm going to graph these points. I'm going to graph the first point, which is right here. And then I'm going to graph the second point, 1, -2, 2, -1, 3, 0, 4, 1, 5, 2, and 6, 3. And I am going to make a line between these points. And I'm going to try and graph the other part of my function by going back to the calculator, try and find the values of y when x is less than 0. So I'm going to look for the y values between -6 and 0. And for -6 we have 3, -5 we have 2, -4 we have 1, -3 we have 0, -2 we have -1, -1 we have -2, and we already graphed 0, -3. So now I'm going to go to my graph again, and I am going to graph these points. We said -1, -2, -2, -1, -3, 0, 4, 1, -5, 2, and -6, -6, 3. And I am going to connect these dots. Now, since my graph doesn't have a restricted domain, the question doesn't tell me exactly from what x value to what x value I need to graph my function, I'm going to put arrows at the end right here. And this is the absolute value function this is the graph for the absolute value function that we have here. If we look at this function, we have we have -3 and 3. These are the zeros or x-intercepts. -3 is the y-intercept and the minimum value. The domain goes from -infinity to infinity as we cross the x-axis from left to right. The range starts at -3 and goes to infinity, and that's our range, and that's how we graph the absolute value function. Now we call this absolute value function a piecewise function because if you look at the graph, we have two pieces here. The first piece is this piece, and the second piece is the piece of the negative values. And since we have two pieces together, we call this absolute value function a piecewise function as well. Let's take a look at our second function. We have f of x equals 2x for every single x between -3 and 1, and -x plus 3 for every single x between 1 and 5, including 1 and 5. This is a piecewise function because we have two pieces for this function. The top piece is the first piece and the bottom piece is the second piece. We have a restricted domain here. If we look at the first piece, we need to include only the values that goes from -3 to 1. And for the second piece, we need to include only the values from 1 to 5. I'm going to graph this function piece by piece. I'm going to start with 2x. I will go back to my calculator, clear y equals, and put 2x, and to have any points or accurate points, I'm going to have to go to the table, look at the x values that belong to this restricted domain, which is values between -3 and 1. So I'm going to include the values of -3, -6, -2, -4, -1, -2, 0, 0, 1, 2. So I'm going to include just these 5 points to graph. So on my grid, I'm going to start with a -3, -6, -3, -6 right here. And then I'm going to graph -2, -4, -1, -2, 0, 0, 1, 2, and I have to stop right here because that's my restricted domain. I'm going to connect these dots, and this piece is going to represent our first piece in this piecewise function. Now I need to graph my second function or second piece of this piecewise function, so I'm going to go back to the calculator. I'm going to put -x plus 3, y equals, I'm going to clear my calculator, and I'm going to put -x plus 3 instead. -x plus 3. I'm going to look at the table of values to find accurate points that I can graph. My restricted domain for this piece is for all the x values that goes from 1 to 5. So that means I need to restrict my graphing to graph all the points from 1 to 5. That means 1, 2, 2, 1, 3, 0, 4, negative 1, and 5, negative 2. So I'm going to go back to my grid and I'm going to graph these points. So I'm going to graph negative, 1, 2, which is right here. I'm going to graph 2, 1, 3, 0, 4, negative 1, and 5, negative 2. And I'm going to have to stop here because I have restricted domain. I'm going to have to connect all these dots together. And this piece of the graph represents the second piece of the piecewise function. I'm not allowed to use any arrows at the endpoints because I have a restricted domain that goes from a specific x value to a specific x value. So this is my function. If we take a look at the main features for this function, we'll find out that the x-intercepts or zeros for this function are 3 and 0. The y-intercept is 0. The maximum for this function is 2. The minimum value for this function is negative 6 right here. My domain for this function goes from, it's from negative 3 to 5, and the endpoints should give you a hint. We have negative 3 to 5, this is our domain, and our range goes from negative 6 to 2, because our graph from the bottom up starts at negative 6 and ends at 2. And this is how to graph this kind of piecewise function.